Hi all, welcome to this MuleSoft video. In this video, I'm going to introduce and explain plugin based deployment for consolidating your many MuleSoft APIs into one single unit and deploy them into a in a single worker. Basically, you can consolidate the experience APIs which was not used much or less complex APIs or less traffic APIs, and or probably you're having APIs that is not reused by anyone else. So those APIs can be basically clubbed together and deployed into a single vCore. When we use API led, we tend to create multiple level layer of APIs, experience, process, and system APIs for good for more reusability. If there are no one else is reusing the application, or when you have less traffic, that time this solution, the business may think that it could be overpriced solution. That time you can combine these APIs and deploy it in a single VCO to save money. This plugin based deployment is not totally different from what we are doing. So in a normal development, we create RAML and publish into an exchange. We create flows out of it in the Anypoint Studio, then generate a new application jar that we deploy that application we deploy into Cloud Hub. The same way we are going to create RAML, that is going to be the same. We're going to generate flow in Anypoint Studio, that's going to be the same. And additionally, what we're going to do is we generate a mule app as a plugin jar. We mentioned that in the pom file this application is not going to be an application mule application. It's going to be built as mule plugin. So that file, the extra step what we're going to do here is we're going to create an application which actually hosts this plugin. Then basically you can host one or more plugins together. So when we create a project for for each plugin, for each API that you create, we create a plugin and a hosting a project as well. So that way, when during the deployment, when you want to stop the old application, the application you wanted to host separately, it will be ready as well. So creating a host project or a proxy project will be an extra step here, and everything else is will be the same. And you need to take care of some extra things that I'll going to cover in during the demo. So for the demo purpose, I have taken a flow here. I'm going to walk through this in detail. There is a global card producer producing events where MuleSoft. I'm going to take it a little more closer. And MuleSoft API is going to constantly listen to this APIs, and global card will make an API call. This MuleSoft API listens to those events and pushes into an anypoint exchange queue. So the anypoint exchange is binded with two queues. One is portal H portal queue. Another is GSAP queue. There are two other APIs which exposed as an API as well. It has a MQ subscriber. It listens a message from the MQ and it calls a local API. So that API is responsible for sending those events in the desired format to Azure storage account. So the Azure storage has a container called GSAP and HPortal. So basically, we are receiving the events from the global cart API, global cart system, and then we are pushing them into GSAP and HPortal. So we are going to see what are the steps needed to convert your MuleSoft APIs into plugin. So here you can see three APIs that we usually develop in order to suffice this requirement. But now I'm going to create three more extra projects, one, two, three, in order to host them. For example, this Gcard API hosting will host this API. The first step is we are going to make this as a plugin. Add this piece of code and it will be a plugin. And in the coding as well, usually we create an implementation file, but now we are having a special thing. We have separated the API kit router as well from the listener. So the listener will not have any router, only it will have only the listener and the flow reference. The flow reference is making a call to this flow, where I have the API kit router. From there, the flows will be the flow will be routed to the right one. But everything else is same. The way you create the raml and publish into exchange and create a project and implement it. So here I have implemented this post customer where it just publishing the messages into an MQ. That's it, right? And I'm hosting this as a I can. So this hosting is an application. Mule is a regular Mule application. It does not have anything. In fact, it just having a flow reference. It's gonna call this flow which is referenced in the plugin. So this plugin has this flow, this expgcmart flow. Here it is. So this flow will be called from this application whenever it gets a request, right? So in order to do that, we have to import the actual file, implementation file. So this hosting application is for hosting one plugin. How it looks like, it has a corresponding hosting projects like hportal has hportal hosting, gsap has a gsap api hosting. So this you will need that when you don't want to combine them and deploy it. So either you have to have a combined one or this or a separated one, right? So let's see how it looks like. The other one, the combined one, the consolidated one looks like this one. So you have a pom file here. It's saying it's a mule application, okay? And what else it has is it has all three raml files and the plugins. So these are the three APIs, raml and the plugin. Now how do I'm going to choose the fun- flow name, right? This flow name is dynamic. It's expected to send it in the headers. When you make a call, you should pass a header called API name. This API name we should call which flow we wanted to call inside. So either expgc this one, or in order to call gc this API, you have to call this one. Otherwise, or you wanted to call gsap API, meaning you have to call this one. So we have seen how Experience API was implemented, but now we are going to see how GSAP and other two APIs are implemented. So we have seen this Experience API, which was pretty simple, which is sending the miss events to an MQ. We have seen this already. Now we are going to see this system layers. So this system layers receiving events from MQ and sending the information to the Azure container. So we have two different containers, one for GSAP and hportal systems, right? So let's have a look at it, how it looks like. So I have tested this application into, I have tested this application. This is the container I was talking about. So I have tested this application using JMeter. I have passed 200 requests spread across 10 seconds 20 times. That means I have created 4,000 records and the results were bit okay. I was able to successfully seen this all 4,000 records in the GSAP and the in the H portal as well. So this is working beautifully, and this is how my application health looks like. It was totally healthy. I will show you how the other two APIs looks like. And it is always so, this is how your runtime manager will look like. You will have all three API hosting APIs. So this API hosting file will have a reference to the corresponding DC card plugin. But this con is a consolidated one. Will have reference to all ramls, all three ramls, all three plugins, right? So if you see this one, when I was processing 4,000 records, even my cloud hub is able to maintain this one work point one worker is able to maintain receive all. I have kept 1.5 kb of records. It's not MB of record, so we need to be very cautious when we using this one. So less traffic, less payload, and not anyone, if they wanted to start reusing it, you go ahead and s- scale out this app, right, and start using that one, and stop with this one later, right? So this was healthy. And I have enabled an API manager. It looks like this one. Yeah, this is the one is active. This API instance is configured in the consolidated app. Discovery is enabled here. So only thing where you would be importing the implementation file or in the trigger file. So I have a trigger file as well as imported from the projects. Like that's what I'm about to show you. Say that take this GSAP system API where I have this trigger as well. What this trigger is doing, it will listen to this MQ messages from MQ, corresponding MQ. Then it will call the local API, which means within this hosted environment, right? So it is hosted locally. So that API is being called. So so how it will look like in Cloud Hub, we are going to call an API inside local. So when you want to call an API, you have to pass the header, right? So this guy is passing this global SAP API main. It the same API is being called. So this flow actually routes him to here. So the first it will go here, right? Then the flow API name is actually being decided here. So the flow will be called, it will come here, and from there it will be routed to here. So it will upload the blob to the corresponding container. So the same way the other one as well is implemented, but it's all going to be in a single space. So this has a disadvantage is when it is going to be explored, then all three APIs will be failed. There is no isolation. That is when you have a complex API, you will go for the API led and you will go for the separate worker. But when you see there is no reusability, when you see very less traffic, only that time we're going to see this one. Or once you build the APIs, you realize that this API is not being used much. That time, you might think about this plugin-based deployment. So yeah, this instance is configured here. So we were talking about the same discovery. This discovery is so you can apply any policy out of it and do it. When you scale out, it will be in a different vCore. That time you can um, create the vCores here. So sorry, you can go and create that discovery here. Right now we don't have a discovery, but when we need probably we need to have two global files. One is having the listener of the local. If the local listener is getting imported, then we might see some conflicts when we deploy it in the cloud hub. That's why we're keeping it separately. And this one is an experimental. You need to do so. Okay, one more thing I forgot to tell you. During this APIs, I am controlling my threads, right? in the both the system APIs. When I have a subscriber, I mean, when I talked about subscriber, I'm not letting MuleSoft to choose how many threads it should be allocating to this run this receiving this APIs. Now I'm limiting into two. The max concurrency is two. At any point of time, there will be two threads. If they are not busy, it's not going to receive any messages. If they are free, then it's going to allocate two workers, allocate two threads to receive the messages, right? So that way, I'm keeping the memory or CPU very less. If you run your application in RTF, that time this modular API, you can have more memory, or you can even here you can increase more memory and have. Okay, it's asking to log in. You can basically scale it vertically and have more power to process those messages. I think I have covered almost. Your comments are welcome. Thank you very much.